Alright, so in this video we'll talk about two different properties of the z-domain, namely the superposition property and the time delay property. So the superposition property basically just says that z transformation is a linear transformation, and what that means is, say if you have a signal which is made up of two different signals. So let's say we have x of n equals to ax1 of n plus bx2 of n. So if we try to translate this to the z domain, we will get this: x of n equals to so this is basically ax1 of n plus bx2 of n in the z domain, n equals to 0 from n. So as you remember from the last video we talked about how to translate from the time domain to the z domain using this formula, and this is what we're just doing exactly here. We're applying the same formula here. And when you solve this, a is just a coefficient, just a number, so a can come out, and then it leads us to n equals to 0 to n x1 of n plus b equals 0 to n of x2 of n, and both of them will have the z coefficient, or z of n minus n, because it's going from n0 to n, so z minus n. So this is just really a of x1 z plus b of x2 of z. So basically that's what the first property says, the superposition property. Even if a signal is made up of multiple signals, that can still be translated into the z domain, and even in the z domain it will be made up of multiple signals. And the second property that I'm going to talk about is the time delay property. And in the time delay property basically says, if you have a signal and you add a delay to it, the delay basically gets multiplied to the entire signal. So say you have, or let's say in a signal, if you have a delay of xn minus 1, so basically this means you have a delay of by 1. So when you convert this to the z domain, this is basically the same thing as saying this is 1 coefficient of 1 times z of minus 1, correct? So this is, you basically have here the k in this case is 1 and their coefficient is 1, so this is basically the delay in this case. So say if we have a signal, let's take the signal to be x of z equals to 3 plus z to the minus 1 plus 4z minus 2 plus z minus 3 plus 5z to the minus 4. And if you add a delay of 1 to it, so what will happen is this thing will get multiplied by z to the minus 1 that we just calculated. So this will become 3z minus 1 plus z to the minus 2 plus 4z minus 3 plus z to the minus 4 plus 5z to the minus 5. So they all get multiplied by z to the minus 1. So as a general rule, how we can summarize this is that if there is a delay, so if there is a delay of xn minus let's say capital N, this will be basically z of minus capital N. So that's what the delay will be. So that's what basically the second property says.